Hello. Today, the topic of discussion is when to use different types of programming languages. The reason why I thought this was an interesting topic of choice and why it's high yield and will benefit you in the future is because oftentimes I see people jumping from programming language to programming language when there really is no benefit to utilizing a different programming language. I've seen it time and time again in which they'll learn a particular programming language because of hype of the people talking about it, when in reality it's the programming languages that they're currently using can do everything that this new programming language can do. It's just that the syntax is slightly different. And in some cases it might be that it's not even as good as the programming language that they're switching to. Thousands of programming languages have been created over time, many used for periods of time, and many have died out. Probably less than 5% of all the programming languages ever created are still in use, and the cycle repeats. This garners the question, why? I, for one, have used many languages. As I said in previous lectures, I've been programming in different capacities ever since I was young, and at different levels all throughout my career, until I started working in it. I've programmed in languages like BASIC, Turing, Smalltalk, Fortran, Python, C, C++, C#, Java. I've used MATLAB and more. Half those languages just simply aren't as popular anymore. So, why choose one language over another? Well, the simple answer is different languages are good for different things. For example, if you've ever used a web application or website, you'll know that there are three main languages that you have to know in order to build out a website on a lower level, unless you're using an app that generates it for you. These three languages are HTML, CSS, and JavaScript. HTML, Hypertext Markup Language, is the base language that all web pages are built in. If you wanted to build a website with just one language, you would have to use HTML. What HTML is good for is structuring web page content. And oftentimes people argue that it's not even a programming language, it's a markup language, because it uses markup to structure the actual content of the page. CSS, or Cascading Style Sheets, is a language that complements HTML. You often use it, you can only use it if you're using HTML. It's used to add a graphically rich element to websites, or create a more graphically artistic website, and this is its strength. That is what it was built for, and that's what it does. It's used to add an element of style, like the name implies. And then finally, JavaScript is another language that complements HTML. It's a programming language used to add an element of computation and dynamic interactability to a web application or website. So I mentioned three things: HTML, CSS, and JavaScript. And HTML and CSS are not considered programming languages. They are more so markup languages. So what is a programming language? Well, according to Google, a programming language is composed of a set of instructions that produces various kinds of outputs. It is used to implement algorithms and functionality. So now if anyone ever asks you, why is HTML or CSS not considered a programming language, you know why. But that doesn't deviate from the point that different programming languages are good for different things. If you've ever used SQL, you know or structured query language, you know it's good for dealing with data. That's what it was designed for, that's what it's good for. MATLAB, if you've ever utilized that, you know that it was built to create algorithms. So it's good for signal processing and stuff like that. It was designed for that, and it excels as that. And more. So, however, when explaining in a little bit more detail the different types and categories of programming languages and why you should use them, I prefer to group them into 3 categories: high level, mid level, and low level. Some people like to utilize different categories, but I find this is the simplest way to explain it prior to introducing the details, because you want to learn on the high level and then delve in. Examples of low-level languages are assembly and machine language. We'll look at examples of that in a moment after we get through this part. Mid-level languages, C and C++, and high-level languages examples are Java and C#. Basically, like everything that has ever been created, programming languages use layers to mask complexity from the end user. And by that, let me give you an example. I just said everything that is created. So this concept doesn't just apply to programming languages. Everything is built off layers of complexity. On this, even the world around us, on the lowest level, everything is composed of atoms. Atoms group together to form materials. Materials are utilized to build things like tables, computers, the camera that I'm recording this on, and even the very clothes I'm wearing, and me myself. So, just like that, you can create complex systems using atoms and their unique properties, or you can use the abstraction of materials in order to reduce the workload and create complex systems without having to deal with things on an atomic level. Or you can use the actual objects that the materials create in order to reduce your work even more. And that's sort of like how programming languages are. On the lowest level, we have assembly and machine language. These are the languages that came first. You can use them to create programs. However, it'll be more work and you have to compensate for more in order to build out a program. Mid-level languages remove a little bit of that work that you would have to do using a low-level language and reduce it because they compensate for that automatically. And high-level languages reduce the workload even more. However, at the end of the day, what your computer and most devices understand is machine language, which is a low-level language. So something called a compiler converts high-level languages and mid-level languages into a low-level language or machine language, and your computer processes that information to run programs. So let's take a little bit of a closer look at that so that you will understand, because I explained the theory, but now we have to look at the actual examples so that it becomes clear in your mind.
So the first thing to discuss is low-level languages, or machine languages. What is machine language? If you look on the right at the picture, you'll see a bunch of zeros and ones. And then, if you look above it, you'll see that those zeros or ones translate into a 2 plus 2 is equal to 4. So basically, what this means is that on the computer, everything, and on your disk, everything is stored as voltage highs and grounds. What this means is that the different components of memory are store a charge. And these charges, or groups of charges, are represented when you see them as characters and operations. That's how the computer processes it. So if we look at this group of zeros and ones, that is actually equivalent to characters. You would never actually type in manually into a computer zeros and ones in order to create a program. A hardware designer might have to deal with this, but as a programmer that's not dealing directly with the hardware and building things out, this doesn't matter to you. But just know this is what the computer understands, and this is what the computer is actually working with on the lowest level. It doesn't look anything remotely like English, and it would be lots of work to actually create a program using it. Assembly language, which is shown on the new slide that I'm showing in front of you, looks a little bit more like English, as in it's understandable, and you might in some cases actually work with it, even though the scenarios in which you would actually build out something with it are not common. The issue with assembly language is that you have to deal with the addresses of different devices. So if you're storing something in memory, you'd have to specify the exact memory block that you're storing it into. Furthermore, you have to specify on a lower level things like subtracting and moving information from one memory location to another. It requires knowledge of the hardware elements like registers and addresses, and is very hardware specific. What I mean by that is that code written in a low-level language cannot often be ported or moved and copied over to another device and work unless that device is an exact copy of the device you wrote the code on. So that's a downside of low-level languages. In order to make it more portable, you'll have to write more code. So the benefits of using a low-level language are that efficient code utilizes less power, and you can write highly optimized code. But if your coder or the person creating the program isn't well versed in it, they could actually write highly inefficient code, and I've seen that in many cases, especially if they're learning the language while writing the code. The cons are that you have more work in order to code out a program, since you have to deal with things at a low level like memory registers and different hardware configurations. Code is oftentimes bound to a particular hardware configuration and not portable. It's harder to hire good developers for it because the majority of developers are not going to code or build things at such a low level. Maintenance of code, furthermore, can get very expensive because bad developers can introduce bugs and inefficiencies. And since you often build systems in teams, you never know who might introduce the issue. So it adds a layer of complexity. So when to use low-level languages? I would say use them seldomly, but when you do, it would be for things like medical devices that are seldomly recharged, for example, heart pacemakers, or robots that will have to run long-term independently without the ability to recharge, interplanetary explorers, cave explorers, etc. Now let's go to mid-level languages. C is an example of it, which is shown on the right. It's looks much more like English than even assembly. It's easier to write. However, it's still pretty low level, as you can see, because you're still dealing with memory. And you need, while not as in-depth of an understanding of the hardware, you still need to understand it to a degree. C++ was an evolution of C, and it introduced a concept called object-oriented programming, which revolutionized the programming industry because it allows for you to write less code, allows for easier code reuse, and better code maintainability. It's much like C outside of the utilization and enforcement of object-oriented programming. Object-oriented programming basically allows for cleaner code to be written and more reusable and maintainable code. So you can write programs with less overhead. The benefits are less coding and less understanding of the hardware is needed than a low-level coder. Automatically gets converted into a low-level language by the compiler. Code is often still bound to the operating system, so while it's not bound to the hardware, like low-level languages, it tends to be dependent on the operating system. So if you write something that works on Windows, it won't work on Mac OS, which is actually a con. So I don't know why I put it here. But efficient code doesn't use as much power, and efficient code is faster than many high-level languages. The cons, it's not portable. When you compile it into a lower-level language, since you're automatically converting it, it might introduce inefficiencies unnecessarily, so it'll be slower than if you wrote it in a lower-level language. But that's negligible, because if the person writing a low-level language doesn't know what they're doing, it'll still be pretty bad code. Still needs a bit of understanding of things like memory management. You have to allocate and deallocate memory. It has many insecure functions that, if used improperly, leaves the system open to hackers easily. And code isn't usually portable between different operating systems. And hiring good programmers is still difficult. When to use? I'd say many of the scenarios are the same as with low-level languages. But if you want to slightly reduce costs, you'd go with the mid-level languages. So in the case where low power use is of importance and hardware resources are limited, as in you have a limited amount of memory that you can use and stuff like that. And now for high-level languages. On the right, we have an example of C# code. It's very portable. It's not operating system dependent. It runs on top of something called a virtual machine, which allows you to run it on any device you want to run it on. So you can write the code once, and it's utilizable in many different areas, which reduces your workload because you don't have to rewrite it for different systems. Examples are C# and Java, like I said. It's the new age programming languages. It reduces workload, utilizes object-oriented principles, has garbage collectors, which is a term used to describe memory managers. So you don't have to worry about dealing with hardware on the lower level. And I'd say use this most of the time. Because if power and resources isn't of importance, because hardware is cheap these days, you'll have less maintenance costs, less hiring difficulty because more people are trained in it, and more. So let's actually look at the benefits. Memory management is done for you, portable between different hardware and operating systems, less buggy code, more people can code it, you have to write less code, and easier to hire and train for because there are tons of resources for training it, easily available. Cons, number one, it compiles into low-level language. So it's going to introduce even more extra necessary code and inefficiencies than if you were to code directly in a mid-level or low-level language. However, as I said, unless the writers of the code write highly efficient, clean code in the mid-level and low-level language, which is hard to hire for, this con is negligible. Furthermore, another con is that you're using a pre-built open source framework, and consequently, if the framework has security vulnerabilities, they will be publicized and all systems built with it will be vulnerable, but a patch will be automatically released. And many people will have access to your underlying framework code since it's open source in many cases. But because the framework is built for you, programming in these higher level languages often have fewer security vulnerabilities, even though when a security vulnerability does occur, it's publicized, just so you're aware. So when to use? I'd say usually use high-level language if energy usage and speed aren't super important. They usually are not. Make sure that the language, which is high-level, is mature and has a large development community that has tested it and built out projects with it that can help you if something goes wrong. Make sure that there are high-quality learning resources that are highly available and cheap, and make sure hiring help is easy. Ask yourself why schools are teaching it and whether the only reason people are learning it is because the teachers are teaching it, because sometimes people just like to use what they're familiar with. Look at the online statistic charts for jobs if a job is all you're interested in. As you can see, there's a decrease in certain languages like popularity like C++ or Visual Basics, .NET, or JavaScript, increase in popularity in Python. I think particularly because of the libraries that it has associated with it for machine learning and such that are free. C# is increasing in popularity as well. Java seems particularly stable. So you can look at the online statistics if you're just looking for a job. But in the case like Visual Basics.net, I think that is actually still a very powerful language. And it has a lot of place for rapidly developing applications. But the issue is not many people learn it, or it's not widely taught in schools. And it's better for application programming and web forms, which has fallen out of popularity. But if you knew how to actually design and use the Visual Studio's suite in order to build out server-side applications, I'd say Visual Basics would be amazing. C# is increasing in popularity, which is another very powerful language. You have to remember Microsoft is a software development firm that uses the programming languages it designed in order to build out its applications. That has to say something, considering it's the biggest software development company in the world. It has numerous software products that have been widely adapted and used. So they're good at what they do, and if you know how to use the suite and accompanying tools for their products, use them. The issue with Microsoft is that they make you pay for a lot of things, but .NET Core is free. Keep that in mind. For how long, I don't know. But yeah, look at the online statistics for jobs, and that's it. So I hope that was informative for you and you learned something. And next time you use a new language, ask yourself why you're learning it and whether it'll make your life easier and reduce your workload and allow you to go home and sleep and work less. And that is all for now. Till next time.